To solve this indefinite integral, we will use u substitution technique. So let u will be our denominator, b to third plus x to third. This is our u. Let me rewrite this. U is equal b to power third plus x to third power. B is constant number. So now when we take derivative of both sides of our equation with respect to x, we will have derivative of constant is 0, we don't have to write, and derivative of x to third power is 3x squared. Now we have to find du. So we will multiply both sides by dx. So dx and dx we can reduce, and we have du is equal 3x squared dx. Because we have in numerator x squared dx only, and on numerator we have u. So we need to substitute x squared dx. In our equation, we have du is equal 3x squared dx. We don't have this 3. So because we have multiplication, we will divide both sides of our equation by 3. 3 and 3 we can cancel. And we have x squared dx is equal, we can rewrite that this is 1/3 du. Now we can come back to our integral, and this is equal integral of, in numerator we will substitute x squared dx by 1/3 du, and the numerator is our u. We integrate with respect to u. Notice that we do not mix x and u in one expression. We have now only expression with u. So to find integral of our function, first we can take this constant before integral symbol. So we have 1/3 integral of du over u. So this is equal natural logarithm of absolute value of u. Of course, don't forget about 1/3. And of course, when we have indefinite integral, we have to add constant c. And this formula is for u different than 0, of course. So now we have expression with u. Now we have to unsubstitute the u. U is equal b to third plus x to third. So this is equal 1/3. We have to copy, and we have natural logarithm of absolute value of b to third plus x to third plus c. Of course, x must be different than negative b. So we are finished.